Okay, now we're moving on to measures of central tendency. You've seen this little line at the very middle in the previous weeks or in the other graphs you see symmetrical. How we define that middle point of our data is mean, actually. Now, there are different ways to calculate the mean, but let's look at the most basic way. The most basic way that we learned is by summing all of the scores and then dividing by the total number of scores. So the sigma sign here, you can see, it just means sum all of the types of data that come after me. So X means individual scores. So it just says just sum all of the individual scores. This sigma just tells us to repeat the adding operation multiple times. N, this uppercase N, is normally used to signify the population member count. But sometimes our textbook has used it to show sample size as well, which is a bit confusing at times, but we will get through it. So the way we calculate mean is you take all of the individual scores and then you divide by the total number of scores. And that gives you the point right at the middle. You get the average, the mean. The median is, for example, you have a data that is 1, 2, 3, 4, 5, 6. Just that. Let me just write it out, actually. 1, 2, 3, 4, 5, 6. Now, you can see how there are 6 total values here. If this were 7, it would be much easier to find out which one the median is, but for the sake of demonstration, let's check it out with 7. So you remove 1 from this side, 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 and 1 from this side. And the remaining number is your median score. Now let's say this is not the case and we have a double digit thing. I forgot what you call those things. So let's repeat the same operation again. Going from this side, 1 from this side, 1 from this side, 1 from this side, 1 from this side, and 1 from this side. Now, as you can see, we are left with nothing. So to counteract this, what you do is you add these remaining numbers and divide them by 2, which yields us 3.5. That's our median. Mode is the most occurring number in a distribution, the most frequently occurring number in a distribution. 3, 5, 5, 7, 8, 5, 9, and in this case, 5 is the mode because it's the most occurring one. It's rarely used in formal psychology research, whereas mean is the most commonly used measure. The caveat with the reason you use these different kinds of central tendency measures is because they all have different sensitivities to outliers. For example, mean is your simplest one, but if you have a village of 5 people who get 5 lira per month as their salary, and then there's Elon Musk in that same village earning $1 million every month, your average income per month for that village is going to be about, what is it? I think about $500,000. So that's not really representative of the actual data that we have. So in that case, we would use median, which would yield us 5 lira. So we compare the measures across distributions. Let's check it out. So in a normal distribution, all of these are at the exact center, the mean, the median, and the mode. However, if it's a right-skewed distribution, as we discussed earlier, it goes mode, median, mean, because mean is the most sensitive, median is the, second less sensitive, and mode is essentially not affected by outliers, but it is. So it's the least affected. And if it's to the left, it goes mode, median, mean again. So what you need to look at is where the peak is, and from where the peak starts, you go mode, median, mean. Just know that mean is closest to the most fucked up one. As stated here, center, mode, median, mean. Okay, now let's see what this is. These are measures of variability. The most important metric or statistic, I guess, in statistics is the standard deviation. But it's only the most important because variance is not easily understood by humans. So let's check out the sum of squares. We are trying to get to the standard deviation. So what is the formula for the standard deviation? You take the sum of individual score minus mean squared. Okay? Sum of the squares. Individual score minus mean squared. Individual score minus mean squared. This repeats for however many scores you have. And then you take the sum of all of it and then divide by the amount of people participating, the amount of values or scores you have. And then you take the square root. Now we will see why this is. So first of all, the reason we don't just add up everything, so we don't just do x minus m and then sum all of it up, is because if we did that, then negatives would essentially cancel out the positives. What do I mean by that? Let's see. Let's switch over to a magma instance. So we have 1, 2, 3, 4, let's say. And then at the opposite side, we have -4, -3, -2, -1. If you add all of these up, you get 0. I think it's quite apparent that you do. But let me show you. This cancels this, this cancels this, this cancels this, and this cancels that. So the reason we take the square of all of those is to get rid of this issue. It eliminates negative numbers, and it ensures that all of the terms are positive. And another side effect of the score or the squaring function is that it boosts numbers that are further from the average. What does this mean? So let's think about 1 and 4, just only 1 and 4. When you square 1, what do you get? You get 1. When you square 4, what do you get? 16. Look at that difference. The difference that would have been 3 in this case is now 15. So it grants a higher weight to scores that are high. So if we have all of that out, then let's move on to the variance. So the variance is essentially the mean calculation, but on the samples or the data set. We are trying to get how varying each point of data is from one another. Because essentially what we are doing right now with the mean is, oh, this is not how you draw. Oh my God. Okay. So let's say the mean is here at 0.0, and you have scores ranging from -1, -2, etc. It's just 1, this is 2. So you have scores like this lined up. I'm just making a made-up scatter plot. So you are essentially calculating the distance of this data point, 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 this, and that. And then you are taking the mean of all of that and getting the average variance or the average distance. The scores vary from one another. I don't know if it's understandable, but that's somewhat the core logic. So, going from this, we take the sum of squares, we apply the same formula to all of the data in our data set, and then we sum it all up. And then once we have that massive number, we divide it by the number of scores that we had. This yields us a magnificently gigantic number if your data set is big. For example, you can get 300 maybe. Because this is not human readable or really usable in anywhere outside of your computations, we square root it. What we applied here with the squaring function, we essentially undo with the standard deviation function. So you get the variance, and then you square root it, and that's the standard deviation. If you see variance, just know that if a data is indicated as variance, if you take the square root of it, you get the standard deviation. And to get back to the variance, you just square the standard deviation. These two are interchangeable, just with a simple square root formula. Limitations and research context. Yes, with averages, as I said, knowledge about individual specific cases are lost in the calculation. This is why we use qualitative research methods like case studies or ethnography, so we can know about individual cases as well. And when you are making your actual report, you rarely state these. You don't really tell the mode, median, or variance. And that's it.